Question 1 says evaluate the integral upper limit pi over 2, lower limit minus pi over 2, and we have the integrand cos x, alright, and differential dx. Now, the first thing, let's go to solution. The first thing we want to do is to find the antiderivative of the integrand, which is cos x. Now, the antiderivative of cos x will become sine x. So this is equivalent to sine x. What's the reason? From differentiation, we establish that if we find the y over dx of sine x, we'll get cos x. So if we find the antiderivative, which is the opposite of the derivative of cos x, we're going to give back sine x. So, and meanwhile, differentiate the antiderivative of the x is giving us as 1. So that we can ignore. So what we have left is now the upper limit as pi over 2, lower limit minus pi over 2, and sine x, right? Now, how are we going to find our answer? The first thing is that we're going to replace the value which are in the upper limit and the lower limit as our value of x, and then we're going to subtract both answers. Let me show you what I mean. So to get our answer, we're going to say sine, alright, sine pi over 2, which is the upper limit, minus same sign again, lower limit, alright, minus pi over 2. So this is what we're going to get our answer. We're going to say sine the upper limit, and we're going to remove the value of sine lower limit, take from our answer. So in general, you find the answer derivative, then replace the value of x for the upper limit and remove the value of x from the lower limit to get your answer. Okay, so we have pi generally is 180. Alright, so sine pi over 2, that becomes sine 180 over 2, which is sine 90. So this is now sine 90 minus sine minus 90. Sine 90 is equivalent to 1, and sine minus 90 is minus 1. So this is minus, open the bracket, minus 1, right? So minus times minus is plus. So 1 plus 1, that's finally going to give us 2. Correct answer is option C. Next question now asks us to evaluate the antiderivative, upper limit is 2, lower limit is 1, of 6x squared minus 2x dx. As usual, we're going to ignore the x. Now, the problem now is finding the antiderivative of this function 6x squared minus dx. So let's go. Solution. We have the antiderivative 6x squared minus 2x, right? Generally, to find the antiderivative of any value, x antiderivative x to the power of n is equivalent to xn plus 1 all divided by n plus 1. Alright, so first we'll find the antiderivative of 6x squared, and I'm going to find the antiderivative of 2x. Then we'll measure them together. So for 6x squared, that becomes, for 6x squared, that becomes equals to x is 6 and n is 2, right? So this is now 6x power of 3, right, divided by 2 plus 1 is 3, so divided by 3, right? So 6x cubed divided by 3, 6 divided by 3 is 2, so this is 2x cubed. Then as for 2x, the antiderivative of 2x, this is now equals to 2x squared over 2, right? 2 divided by 2 now, so that become 1, so this is x squared. Combine it, so we have 2x cubed minus x squared. Now we'll replace the value of x as the lower limit and the upper limit. The upper limit is 2, so we're having 2, alright, 2 cubed minus, in the bracket, 2 all squared. Let's put this in bracket, minus. Now replace the value of x. Remember, it's the whole function we are considering, so replace the value of x now for the lower limit, which is 1. So that now becomes 2, open bracket, 1 to the power of 3 minus 1 to the power of 2. Alright, so 2 cubed is given us to us as 8. 8 times 2 is 16. 2 squared is 4, so that's minus 4. Alright, minus 1 cube is still 1. 1 times 2, that's 2 minus 1. Alright, let's go. 16 minus 4 is what? That's the same thing as 12. It's minus 1, that's 1 as well. So 12 minus 1. 12 minus 1 is equivalent now to 11. So the correct answer, the antiderivative of 6x squared minus 2x is 11. Option D. We have a question that says evaluate the antiderivative of function cos 4x plus sin 3x dx. Option A, sin 4x minus cos 3x. Option B says sin 4x plus cos 3x plus k. Option C, 1 over 4 sin 4x minus 1 over 3 cos 3x plus k. D, 1 over 4 sin 4x plus 1 over 3 cos 3x plus k. That's right. Alright. Now, first off, we can eliminate option A because it does not involve a constant. Generally, when you find the antiderivative of a function, you must include a constant k, since if we are to differentiate your answer, definitely k will yield 0. So it is always safest to assume that there is a constant so that we don't know. Alright, so now let's solve. As we did before, to evaluate a function which consists of multiple entities, like in this case we have cos 4x and sin 3x. Now we want to find the antiderivative of everything here. We are first going to treat them as single units. First, we find the antiderivative of cos 4x. Generally, if you have the antiderivative of cos ax, where a is the coefficient of x, we'll have that this is equivalent to 1 over a cos, that's sine ax. Right, so the antiderivative of cos ax is 1 over a multiplied by sine ax. If you observe, if you differentiate sine, ordinarily, yes, you get cos. So, and a, which is a coefficient, you have to multiply it by your answer. So generally it is 1 over a sine ax. Now let's apply that to cos 4x. Remember, a now takes value of 4, so we'll have that this is 1 over 4 multiplied by sine 4x. So we've evaluated the antiderivative of cos 4x. Meanwhile, for sine, so if you actually find the antiderivative of sine ax, now this one, it takes a different shape. What do we get? We get that this is equals to minus 1 over a cos ax. So now let's impute it as sine 3x. So the antiderivative of sine 3x will be equals to minus, remember a is 3, right? Minus 1 over 3 multiplied by cos 3x. So this is the antiderivative. Remember, we are treating each function individually. So we'll have that our answer here, the antiderivative of cos 4x will now be, which we got as 1 over 4 sine 4x plus, you open the bracket, minus 1 over 3 cos 3x. Alright, so we have plus here, we have minus here, plus signs minus, that gives us minus. So our final answer becomes 1 over 4 sine 4x minus 1 over 3 cos 3x. Alright, so that corresponds to option C, right, with the inclusion of a constant, which is k. So option C becomes our correct answer. For evaluate the integral 2 in bracket 2x minus 3 to the power 2 over 3 dx. Now this is quite a complex question, but first let's analyze. Alright, solution. Now if you observe 2x minus 3, if I find the integral or the first derivative of 2x minus 3 as we did before, I'm going to get 2. So I can say that, for example, let me present 2x minus 3 with a constant. Let's say that 2x minus 3 now is equals to u. If I differentiate it, du with respect to x, right, we'll get 2. So this is equals to 2. I can make du so much a formula saying that u is now equals to 2 dx. So now let's replace du, the constant here. Let's replace it here. Alright, so we'll define the integral of 2x minus 3 to the power of 2 over 3 du, which is now what, 2 dx. Now, first off, let's focus now on this 2x minus 3 to the power of 2 minus 2 over 3. Remember, we said that 2x minus 3 representing as u, so this is s u to the power of 2 over 3. Now, the general formula is that whenever you have s, alright, remember we said whenever you have generally s, which is the integral of x to the power of n, this is equals to xn plus 1 over n plus 1. So u to the power of 2 over 3, that now becomes u 2 over 3 plus 1 divided by 2 over 3 plus 1. Right, so this is equals to u. Let's evaluate 2 over 3 plus 1 as denominator. Then we'll just replace the value here to make it less complicated. The LCM in 3 and 1, here is 3. Alright, so we have here 2 plus 3. 2 plus 3 is equivalent to 5, right? So we'll have now that 2 over 3 plus 1, which is in the exponent of u, will still give us 2 plus 3 divided by 3. So this is now equals to u 5 over 3 divided by 5 over 3. The inverse of 5 over 3 is 3 over 5. So this is 3 over 5 multiplied by u power of 5 over 3. And we said that u is 2x minus 3, right? So we have 3 over 5 multiplied by u, which is 2x minus 3, raised to the power of 5 over 3, and usual add our constant plus k. So this becomes our final answer. Last question is question 5. It said evaluate the antiderivative of x squared plus 3x plus 2 all divided by x in bracket x plus 1 all squared dx. Now, first, the function we have to find the antiderivative of is a bit complex, and we're going to have to simplify it first. Let's go solution. Solution. X squared plus 3x plus 2 is in a quadratic form, and generally for quadratic equation we can find factors for quadratic equation. So let's write it out first. X squared plus 3x plus 2, we're going to find out the factors, right? And we'll see what we can do about them. Now, the factors are going to be, what are we going to times that will give us 2? Now, since this is 1 that's going to x squared, we can ignore that. What are we going to multiply? That will give us 2, and then when we add, we give us 3. Obviously the answer is 2 and 1, so I can say that this is also equal to x squared plus 2x plus x plus 2. All right, now what we're attempting are the coefficients, which are here is 2 and 1. So 2 times 1 is 2, 2 plus 1 is 3, 2x plus x, that's 3x. Now we're going to find out the factors. Now, x squared plus 2x, what's common between them is x. So this is x, in bracket we're having x plus 2, right? Plus, there's nothing common between them, so we write 1 in bracket x plus 2. So since x plus 2 is common, we can pick 1 and say that this is equals to x plus 1 divided by, multiplied by x plus 2. Alright, so now let's write that equation again. So I can say that we're asked to find the antiderivative of x plus 1, x plus 2, all divided by x, x plus 1, x plus 1. Remember, x plus 1, x plus 1 is the same thing as x plus 1 all squared. So we have x plus 1 in numerator, we have x plus 1 in denominator. We can cancel them out. What we'll be left with is x plus 2 over x plus 1, right? Our next goal is that this fraction, we want to simplify it. What I mean simplify is by decomposing. We use the partial fraction decomposition method, which is a topic we'll treat in another video. But now, to decompose this, we say that x plus 2 over x bracket x plus 1 is equals to a over x plus b over x plus 1. So we're going to look for two numbers, which are a and b, that when I find the denominator, which the LCM of the denominators, which are x and x plus 1, and then I do operation on them, I should get that my value of a and b, what will form the numerator, should be equal to this x plus 2. So I will say that x plus 2 should be equal to a in bracket x plus 1 plus bx, right? So a x plus 1 plus bx. Now I'm looking for values of a and b. First off, let's make a 0. Let's make a 0 so that we can find b. To make a 0, I'm going to take x as minus 1. So if x is minus 1, we'll have minus 1 plus 2, that's 1, is equals to minus b. Therefore, b is equals to minus 1. Now, if I make x 0, that's the value of x. If I make it 0, I'm going to get that b automatically becomes 0, right? Because 0 times b, everything give us 0. Alright, so, and here, if x is 0, 0 plus 1 is 1. So we have that 2 will be equals to a. Alright, so a is equals to 2 in general. So b is equals to minus 1, a is equals to 2. Alright, now we can now write out the composed fraction is a over x plus b over x plus 1, right? So if I place the value of a and b, we'll have 2 over x plus, open the bracket, minus 1 x plus 1, right? Now, so let's write out our new equation. So we are now asking us to find the derivative of 2 over x minus 1 over x plus 1. So this is our simplified equation, dx. So now, since this is simplified, we can now implement a new rule. What is that rule? That generally s, that's, sorry about s, but that's the antiderivative. No, this is not s, but generally s of 1 over x, all right, where x is any kind of function, is equals to the natural logarithm, which we present as in of x. All right, that's natural logarithm. So if we impute that here, we'll have that the antiderivative of 2 over x, okay, now becomes natural logarithm of x all squared. The reason is that generally 2 ought to be at the side here, which is multiplying here, but I said all squared because of a law of logarithm. Now we can treat, if one wants to treat logarithm, you can drop in the comments, but in this is the same thing as in x all squared. Then as for the other function, which was 1 over x plus 1, this simply becomes the in, which is natural logarithm of x plus 1. So combining both of them, we have that our function, which was 2 over x minus 1 over x plus 1, will be equal to in x square minus in x plus 1. As usual, we had our constant k. Alright, so this is our final answer. Thank you for watching.